Today is important because I know many of you are using digital elevation models or other tools for your research. So today we're going to show you how we can actually download a DEM directly from Open Topography using Victor and actually use that for your own research in a model or something like that.
I have made two notebooks. I'll be going through one in the session today, and then one will be for you all to kind of work through. I've left most of that one filled out. It's more just to familiarize, but they're both in there. So for the sake of organization, I'm going to make a new folder. This will be like DEM activities. Uh, I recommend making folders for your different content, whether it's the models or notebooks or something in between, just because when you suddenly end up having 50 files in your home directory, it can get very cluttered. That's more of a organization thing. So if everyone can navigate, it's the shared folder in Victor courses. I've made a folder for this spring 2025, and this is just for week 2 so far. If you can, all you need to do is right-click on this short course notebook, and you can copy it, and then I'm going to paste it right in here. And after a couple seconds, it should be up. If everyone can take a moment to do that, that would be great. And then, I'll give it 15 seconds. That's that's what we're gonna start going through. What I will also say is, if you want to download any file, like any single file from Victor, you can right-click on the file, and there's a little download button right there. You can also do it from, I think, somewhere up here, but I find generally the easiest way is to right-click and download, and then you should be able to see on my screen, like right there. It's just downloaded onto my machine locally. So you can do that for visualizations. You can do that for the raw data, for like these DEMs, if maybe you need to transfer it to some like high performance computing or some other system. But that's just one example of how to download things. Anyway, I'll get back into the main portion. So I'm
One,
focusing today.
sorry,
Oh,
one note
yes.
also the opposite. You can also upload files. Sam can show that little upload arrow on the
Right, yes,
menu
you
if you want to
can.
upload.
I don't know if they'll see my like
Yeah.
can you see my kind of
Mhm.
Yep.
Mac window? Okay, yeah,
Yeah.
so then you can just upload things from there.
Yeah. So there's like on the file menu, there's like a little arrow to upload if you want to upload your own DEM, if you want to upload an input for something else, some data, can easily do that too.
Mhm. You can also drag and drop for uh most cases. Sometimes I think it might not work for an entire folder, but uh if it's, oh, I need to upload this data real quick, you can just drag and drop from your computer, and uh it'll be done in seconds. Okay, so what I'm focusing on today are DMs, the kind of associated raster format, and then other related tools. So I'll try not to go too in depth in some of these because I assume many of you having some experience understand the overall ideas. But the primary formats we're going to use, at least on Victor, will be ASCII, like Esri ASCII shapefiles, and then TIFF or GeoTIFF files. That is mainly because they're open source, they're standardized. We don't want to go to some niche, closed source or paid version. We want to make sure everything is available to everyone. So the former ASCII, it's what's called like human readable. So if I try to open a an ASCII file on here, it's just a bunch of like numbers. It's the actual elevation data, and that's easy for us to read. Um, but in terms of a TIFF or a geotiff, it's not human readable. It's all binary. So it's more efficient in terms of storing space, so we can't read it normally, but it also has more parameters just baked into the file, so it has georeferencing or might have multiple bands. So there's, different uses for each of them, but so, at least on Victor, some models require one or the other, but generally speaking, they're fairly interchangeable. All
So
right.
there was a
Yes.
question about how much storage space each user has on
Mhm.
Victor.
So right now it's about 100 gigabytes per person in their home directory.
Yeah.
That's at least what we've allotted. I think like a longer term plan would be to have a more like separate bucket or some more proper kind of database for uh model outputs like large scale or high resolution DEMs. But right now, if you want to work with very large amounts of data, let us know beforehand. But otherwise, feel free. Like most DMs are maybe a couple gigabytes at most. So then those you should not worry about. Okay. Any other ones? I can't see the chat from here.
No, I
Okay.
can tell you if there's questions. I'd stop you.
Great. Okay, so first what I'll do, as with many of these, is import all the libraries, otherwise we can't get anything to work. I'll take a brief aside in a moment. Here we're using this Victor library, this Victor package for the first time, which I talked about briefly last time. It's just a bunch of helper functions. So what I'm doing here, I would recommend all of you try with your own, favorite volcano. I'll stick with what I have here for now. But I looked at Pinatubo here. This is using the Smithsonian Global Volcanism Program database. I would say 95% of the time you look up a volcano, it will just be the only one, the first one that pops up. Sometimes there is, if there's an accent mark or the volcanoes with similar names, there might be more than one that pops up, and you might need to look at the variable. Just you can. So after I run this, I'll just show briefly. So you can see, in this case, it only returns Pinatubo, which is great. I can't think of an example where there might be multiple off the top of my head, but this variable, like volcano, will always show everything that matches the search in this function. If you're interested in actually looking at the Victor library, it will be in the libraries folder and shared. It's right here. There is also documentation for it on our Read the Docs page, but if you want to really look into it, it's all here. So continuing on, I just ran this cell. Let's talk about it briefly. So this is just grabbing, as you can see from the output, the actual Latin long of the volcano. This is not necessary right now, but a lot of it is just getting a bounding box so we can actually properly download and set the bounds for downloading a DEM. I'm running another library here called UTM that allows us to switch between lat long and UTM and vice versa. And then we're also specifying here, do I want ASCII or TIFF? I'm specifying a TIFF here. Do we want the name of the output file? So I'm just setting up to Pinatubo here. And then the data sets, there's multiple different ones we can choose from. I can jump down here. This is a list of the data sets that are available on Open Topography. So you can see there's some for bathymetry, but more or less, I would say the best ones to use consistently are the Copernicus or the SRTM. They just have the overall most consistent coverage. All right, so we picked a volcano. And now we can download DEM. Before we need to do that, or before we do that, we need to do a quick calculation for the UTM coordinates. So in this case, I'm using another library called PyProj. If any of you have used like Proj4 or that type of notation, you'll find this very similar. So this is me just taking the latitude and longitude, specifying the zone, and applying the vent location for Pinatubo. And then I print it out right here, and now we have it properly. So now is the fun part, at least to me. We can actually use Victor to very quickly download a DEM. So in this example, I'm taking the approximate. It's about it's like I think 111,000 meters on either side. So this would be about 5 kilometers, give or take, on either side from the vent. And I'm specifying just those bounds. So the latitude plus or minus 5 kilometers, and then longitude plus or minus 5, and then Copernicus and an ASCII file. So if I go back to my DEM folder and I run this, and I wait a moment, all right, there we go. Yeah, so the files are still a few megabytes, and it's also going through their API, which I'll jump to in a second. But we have it right here. I can open it up. There's a bunch of data. That's all we can really hope for. So there's another similar option where you actually specify the UTM coordinates. This one I made slightly different. So specifying UTM, you're specifying the zone, and this one I asked for a TIFF instead. I'll run this as well. Oh, it's not liking something. All right, I'll have to double check that. I might have made a hiccup there.
Yeah, I got that error too.
Okay. Yeah, that was. I thought I'd run through everything fine, but there's always bugs. For now though, it's not super important. We can skip that. I just wanted to demonstrate that there was another option for excuse me, for downloading. I could also change this to TIFF, and if I give it a moment, it will work just as well. I
There's a
generally
question.
find
Sorry,
yes.
Sam. There is a question about the name that you put for the DEM. So is there a way to check the database for spelling volcano names? For example, when the volcano has got like 2 words or 2 plus words, like Mont Pelée or Mont Saint Helens. What are the words that you need to put in there? So is there a way to check like what is the exact word we should put in there?
There's really only 2 ways that I can think of. One is just going to the GVP and looking at how they enter it there. Otherwise, I would do something like
Yeah, what
this. Go for it.
we have, or we can add that a copy of the VGP Excel spreadsheet, which is what we use for the database. So you can just essentially open that Excel spreadsheet and see what's in there, because that's what we're working from.
Okay.
So yeah, I went real quick to check. Like, so for Mount St. Helens right here, this is how it's entered in the database. So it's not super clear, and You know, maybe we'll think of a way to make it a little bit more straightforward, but yeah, that's how we currently have it working.
Yeah, looking at the list is good. Yeah, thanks Gustavo for sharing the link to the volcano list.
Where was I? Okay. Keep this out of the way for now. This I'm also going to leave off the table for now, just because it's not super important. But we also implemented a version for USG based on USGS data. It goes down to 1 meter. It's like it's I think all 50 states in the US, and then like a little bit on either side, like in Canada and Mexico, and like there's some spot parts in the rest of North America. But if you want to do high resolution modeling, you can also just download directly from the USGS. Okay, yeah, so what I'm also doing here, so I'm going to do real quick. This is all as I showed you here. This is, you can see it's all in latitude and longitude, which generally is fine, but sometimes if we want to do more precise measurements, it's better to convert it to UTM. So what I'm doing here is I'm just going to put in the name of our file. So it's, oops. You can see it autofills there, so we have that all good. You can also, I should clarify, there's a file name attribute where you can just do this and then say, you know, test file dot ask or dot tiff, and then it will save to that name. This is just the default. It's in case the user doesn't add it. I just tried to kind of add as much information as possible. It's, you know, the bounds, the like the data set they pulled from, and then the timestamp. Anyway, so if I run this now, it just output another file. So here's open topo, and now it's in UTM coordinates. All right, I'm going to take a brief aside to look behind the scenes, like I said. So if I go here to open topography, if you haven't heard of them, they are pretty incredible. It's I think it's like an NSF funded organization, and they do exactly what it says here: high resolution topography data and tools. You can see they get like occasional federated data sets, but they also get data just from across the world. You can see New Zealand here. You can so we have the API already set up, but you can use your own API key and request access for specific data sets. There's also a great map that they have. So again, most of the time we recommend just using our download DEM functionality. I think all in all, it should be fairly straightforward, especially if you reference the documentation. But if you want to see exactly what's available at any given place, let's, like, for example, I'll go to the Big Island real quick. And then you can select a region, and just pick some area in the middle, and you can see it shows you exactly what's available. So here's everything that's open, like all the open data. So this you can just, you know, no registration, no nothing, just say, I want the elevation data from this chunk of the Big Island. You can see there's some special access for the USGS one, which we provide on Victor. And then there's some more. We have point cloud data from Kilauea 2018. And then, so again, some more from the USGS, coastal LiDAR, and then geomorphic. So this is just one example. I thought, you know, there'd be a lot of good stuff to show on the Big Island of Hawaii, but this is one option that's this is what Open Topography can do. And then I'll also show real quick their API documentation. They just have a couple of endpoints, which is functionally what we're using right now. It's the global DEM, which I talked about already. It's you give a bounding box, the output format, API key, and then similarly for the USGS, you can choose between a couple different data set resolutions, bounding box. Again, very similar, but we've abstracted this mostly away through these functions. If you're interested, I highly recommend just digging into Open Topography. They're just a really cool company or organization. So what I can do now is, based on everything we've run before, is use the plot DEM function on Victor. Give that a moment. And you can see right away we have easting, northing, and so right now I have it just set to a default hillshade. I can't remember the exact format, but there is a way to specify it otherwise. So sometimes the hillshade may look a little, off, but more or less here you can see it. You can see the caldera and all of the kind of contours around it. So now I'm going to go back to a couple more websites just because these are
just before we move into the some. So
Yes.
for those who have the same problem as we are, where it's say like easting out of range or things like that, what's how do we fix that?
That might just be a bug with the function that I need to take a look at. For now, you can ignore these two, the download
Okay.
DEM, UTM, and yeah, the only one that matters right now is this first one.
The first one, okay.
Yeah, I'll probably get a fix within a couple minutes of the class ending. It's just I want to make sure we keep time well.
Okay, thanks.
Yeah, I'm sorry. This is the life of like debugging. Okay, so for like manipulating or working with DEMs or rasters in Python, there's really two libraries, and then one that kind of packages them together that I want to focus on, and they really should let you do almost anything you want. It's instead of using any GIS software, you can just do the same thing right here, and I find that sometimes it's even a little bit quicker and simpler. So Raster.io is a way to, as it says, access geospatial raster data. So in this example, it opens some TIFF file. It reads the data mask. It can pull geometry. You can transform it between different coordinate reference systems. And let's see. So lots of command line user guides, but you can read the raster data. So here it's showing like the first band. You can do spatial indexing. You can even create more data. It's just this is just a good way for kind of sanity checking. If you want to do more kind of in-depth work, then Xarray is for like multi-spatial, multi-dimensional arrays in Python. So let's see if I can find a quick overview. Okay. Right. So as you can see, you can set dimensions, you can set coordinates. It's just very quick to work with multi-dimensional data. You can index very easily. So this is getting this is like the first row and then all columns. And then it says so you can go by location. So this is getting specifically where x is equal to the x dimension is equal to 10. So we're just getting a specific subset of the data. You can do select by the actual label. So this is integer select, and then also like specify multiple things. It's very similar to the dot lock here, but you can say x equals 10, y equals 20, and then get the specific values of that data set that match those. So yeah, it's just very scalable. So even if you have a data set, or maybe you have a DM or a raster that's multiple layers, because like what we're working with, I should still have some of this up. What we're working on for the remote sensing, this is just one band of a raster that has multiple layers that are pulling or that classify different data. So the X-ray is a good example of just pulling a specific band or a specific layer from all that data. Okay. And then the last thing I'll touch on briefly is this thing called Rio X-ray. It's what I end up using the most. It packages those previous two that I just talked about together. And you can see there's notebooks here. I'll probably post this once I'm done speaking, because I think it's just an incredible tool just for doing things quickly. So this is a way to do resampling very quick. You can see in, what is this, like a handful of lines of code, this loads the raster in, and then this is 7 lines of code functionally. You've now upsampled it, but I think they upsampled it by 2 times, and you can also specify like how to resample. It's just super quick. I also, you can see I've looked at the like convert to data set. You can pull in like a netcdf file, and then in literally one line you can convert the exact like slice you want to a raster, and it's that quick. And then you can see other things here: transform bounds, like clip it, cloud optimized geotiffs. If you want to be more scalable, Dask is a way to kind of split and parallelize your code. So especially if you have maybe multiple gigabytes or tens of gigabytes files, super high resolution, and you want to do some calculations on it, this is a good way to break it down. Yeah, this is just like reading it in chunks. All right, yeah, so those are the 3 libraries I wanted to talk about, like right off the top of my head. Now I can show real quick that we can, this is, as I was talking about before, Rio X-Array. Excuse me. And I can just run this, and now you can see I've just basically pulled all the data from Open Topography, or from this opentopo.ask file. If I want to look at it more, so we can do a couple things very nicely. You can just do that should be DM array dot plot. And right away you kind of see what we had here, but now it's giving us a little nice color bar with all the information. Again, the victor.plot does it, like, makes it much nicer and clarifies some things more, but in this case, this just, a one-line thing you do to plot. We can also look at dot values, and you can actually see all the data in there. We can do let's see. I'm trying to figure out a good value. We'll just do, oops, x equals 1. So now you can see I just got a specific band. It's where it's the, I guess this is actually the second index, but x equals 1, or the second index in the x coordinates, and then takes those, and then so you can see it's just 1x and then 360 values in the y. But now we have a nice kind of slice. That is also what we're going to be asking you to go through with the take-home exercise, which I'll just show briefly. And then we can do a little discussion, I think. So what I have in week 2, it's called take home. You can do this with another volcano. A lot of it is somewhat similar to the beginning or to what I went through, but then from there we're working on actually taking a cut of 1 kilometer extraction profile. So a lot of this stuff is built in, but like what you can see here, what we're doing is calculating the angle. We're actually making a proper, making sure like the arrays are the same size. This just, you know, as it is a take home, I'm going through it very surface level. It's very good to look through more in depth. But in the end, what you're going to have at the end of this assignment is an input file for PyFlogo, which we're not asking you to run or anything, but it will pop up. I can't remember what week, but in the next few weeks. So it will allow you to have basically a custom file for the volcano you're interested in that you can then input into a conduit flow model. All right, that's, oh, okay. And then I'll take, 2 minutes just to clarify something, and then I can hop over to QGIS for a few minutes to talk about that, and then I think that's the end of my segment.
There's a question about is it possible to use my own DEM? So yes, you can definitely use your own DEM. All you have to do is to upload it using the little up arrow button, and then you can upload your DEM. And depending on the format of your DEM, you can then import it into a notebook. And so then you can use it. All you have to do is to read it first inside the notebook, and then once it's read, then you can then just use it as if you were downloading a DEM from Open Topography. So you don't have to use the Open Topography database. You can use
absolutely.
your own database.
So in this take home, these first few cells up until here, these are all just kind of an example to excuse me. This is just a way to download one from Open Topography. But starting here, if you have like Momotombo .tiff, you can put that in here. You just you type in the name here, and then from there you can just continue on as using your own file.
So all it has to be is in your directory, right? To just upload it in your directory, and then
again, and then for this one, as I did with the short course, you're gonna want to copy this and put it in your personal folder, because first of all, just for organization's sake, but also in the shared folder, everything is read only. So if you actually try to write something, like if you tried to put anything in this folder, it's going to say, oh, this is invalid or unable to. So definitely copy everything out. That's why we also have, like we asked you to do for the previous take home, is the Victor setup, that we kind of have this well preserved and managed shared folder with all the models and the notebooks that aren't meant to be changed until you copy them over with Victor setup, and then you can do whatever you want. Okay, yeah. So
the other thing I wanted to mention is that in addition to Raster IO, X-Array, and the other tools, you also have all the GDAL library. I don't know if you mentioned this, Sam.
no,
maybe.
absolutely.
Yeah.
So I
So,
can.
I mean, for those of you who are familiar with GDAL and that are using GDAL library on Linux, then you can just use these command lines from GDAL directly, like a GDAL translate or, whatever, GDAL info, yeah. And yeah, with the terminal like Sam is doing right now. And then all of this is already, all these libraries are already in Victor, so you can use that directly.
But yeah, like GDAL warp, GDAL translate. I just am more
Okay.
comfortable with like doing those things through Python now, just because that's how I, I found the best work for me. But you can see here, but you can also see like the difference between a TIFF or a GeoTIFF file. It actually has the coordinate CRS built in. You can see a lot of data here, and it also shows the exact bounds in the lat long. But then if I go to the ASCII file, you can see here. Let me do that a little bit clearer. You can see there's a lot less data because it's not built in. So that's why, generally speaking, I recommend using TIFF files if you can.
Yep.
But ASCII they get the job done. I like efficiency, and GeoTIFFs do that very
And
well.
TIFF and the TIFF format is also much smaller than
Yes,
ASCII.
exactly.
ASCII is a text file, so if you have a DEM that is pretty big, it's gonna fill up your storage space pretty quickly. So GeoTIFF is really
Right.
it's much
So
smaller, so it's much easier to use.
if you can see, these are the exact same data. This is the ASCII file. It's 2.2 megabytes, and this is the GeoTIFF. It's 540 kilobytes, so it's about 1/4 the size.
Yeah.
And this is for a small one, so you can imagine if you have something that's 100 gigabytes, having it down to maybe even a fifth or even like a tenth, because of just being compact. That's why we really like. Well, that's why we like GeoTIFFs. Great. So continuing on, if you're able to, or if you can follow me, so you can press the little plus at the top bar, or in this top bar, and open a desktop. And then we're all gonna make our way to QGIS. So you can see, I don't know how much I talked about this last session. We have, I think, everything you should need, which is QGIS and ParaView. There's a browser that I can. This is just Firefox. Maybe it's like, oh, I need to look something up quickly, or even if you want to download something. This is also connected to where's that? The file manager. This is connected. This is my home directory. This right here is exactly the same as this. So everything is everything is kind of connected and in its little bubble, which is what we're trying to make kind of an all-in-one resource for everyone. So opening QGIS, letting it load. Right now I'm just gonna load a raster and then show you like one quick example on how to get a contour out of it. So let me see if I can actually. So, is it too small, or can you see it more or less?
That's good.
Okay, I just wanted to
Like
make
it's
sure.
on my screen is okay. I got a big screen, but it's okay.
All right, so in this case, it's as simple as we're going to add layer, add raster layer. And then what I'm going to do, we can go right here to the 3 dots. It's going to open a little file folder. I'm going to go back to my home folder, and you see this is the DM activities folder I made, an hour ago. And let's take this GeoTIFF one because I've sung the praises of them so much. So if I do that, I click add, close, right there, and we have a nice little output of that. And then from here, there's a million things you can do, but there's this tab for raster specifically. There's a raster calculator. You can see basically you can either overlap rasters or just very, very quickly do operations on them. So you can even do like logical. So maybe there's gaps in your there's gaps between 2 DEMs of the same area. You can basically overlap them and use the raster calculator to like say if this one has data, use this, otherwise use the other one, and that can fill in some gaps. So that's it. It's just a very useful tool, but
Yeah,
that's
for those
only
for those who are familiar with ArcGIS, there's exactly the same thing on ArcGIS, the raster calculator. So it's exactly the same tool here. So that's a really great tool for manipulating any raster.
Yeah, and then I'll highlight that the reason why we use QGIS is, again, it's open source, it's free. That's also why we don't support MATLAB currently. It's easiest, and it's also, I think, best to kind of support the community and encourage this kind of use through open source software. So, and QGIS as like it has most, if not all, of the tools that other GIS software have at this point, and you can add plugins and like additions. So it's just super versatile.
Yeah. Well, and right now, I don't know if it's the same on other universities, but our university just moved to ArcGIS Pro, which now require internet to actually just open it. So it's terrible. Like if you're going somewhere where you don't have internet access and you just want to use ArcGIS, you cannot do anymore with the new Pro version. So yeah, I really encourage you, for those who are still using ArcGIS, to switch to QGIS because it's free, open source. It's got most of the stuff that you can do with Arc. You can also do it with QGIS, and it's got some additional libraries in there that you can use. So yeah, definitely make the move if you can.
I'll find the toolbox later, but what I will show now, so there's all of these like great little things that you can look, merge rasters, like reproject, convert. You can you can convert to or from vectors, which there are use cases for, but we won't cover right now. But in this case, this is very quick. We're just taking the input layer, the first band, which there's only one band in this case, and then let's do 100 just because 10 is a little bit cluttered. But all I need to do is run that, and if I close this, you can see, maybe I can.
You can do 50.
No, it's more just the coloring because it's a little hard to see here. That might be a little too much, but yep, okay. So don't do that. How about this? Okay, that's much better. Yeah, so this is again, this is just on the base raster. We haven't done hill shade, we haven't done any cleanup, but with a handful of clicks now, we have this nice contour, and this is all inside Victor. We pulled the DM from the cloud. This basically, we've haven't touched anywhere on the ground. We've been in the cloud the whole time, which is part of the point of Victor, and it also is just it basically makes it everything technology agnostic. It doesn't matter if you have, a 15-year-old computer or a 5-day-old computer. Everyone gets the exact same experience here. So you should be able to, if you were following along, either doing the exact same with Pinatubo or another volcano, you should have gotten a very similar output at the end of this. I think that's about it for me. If there's anything else you want me to highlight or discuss, I'm happy to do that. But that was all I had for today.
Well, let's just go back to the notebooks that the participants have to work on. So the first one is the one, the short course.
So
right?
this is the one I walked through during today. I recommend going through it again. I feel like there's a decent amount of like little information here. But the other notebook is in Victor Courses, Spring 2025. It's a couple of folders in, but it's this take-home assignment. It's actually slightly adapted from a previous workshop, so I actually have some of the solution notes here to explain some of the kind of work through to people. There's really only a couple places we need people to add data, like just setting file names or creating larger or smaller slices. So this is what I want everyone to go through. If you have errors or questions, ask them on the forum. If they're larger questions, bring them to class next week. This is just kind of a good, medium level Python exercise. So I wanted to familiarize people with some of the capabilities of the libraries I talked about today, but also set up for PyFlogo and also just get people interested in poking around in Python.
You also show, Sam mentioned way to extract the profile through QGIS. So I can demonstrate that. This is again on Victor. So I opened the desktop and opened QGIS and uploaded and then used a DEM that I got through Victor. And then I have here, see this little green icon for a raster profile toolbox. So I got that by going to plugin and then manage and install plugins. And then you can look for profile, and this is the profile tool. So if you don't have that in your installation, you can add that. And then you'll have this little icon. And when you click on it, you'll see this part of the screen, and to use that you need to pick the layer that you want to take the profile off, add it, and then you'll have the marker, so you can say draw a line and then double click to end the line, and then it'll give you a profile. And then you can see that data as a table, and then either copy it as a copy to the clipboard with coordinates, which I think is the most useful, because otherwise it just gives you distance and height. Or if you do that, that's your coordinates. And then if you go back, say to a text file,
You're in the shared folder, which is why it's probably not going to work.
Right. Oops. Sorry, that was not the profile. I do it here. Then it just spits out all the data. And then you can use that profile, for example, to run things that run on a topography profile like PyFlogo.
Nice. Cool.
I just showed you 2 ways to do that.
Mm-hmm. Yeah, super useful. Yeah. Cool. Yeah, so I think we have time for questions. Is there any questions from any of you you may want to ask now? Please do it. Don't be shy. Yeah, Jordan?
Hi, just on the thing that you just showed with the profile, is there a way to do that for, say, a river channel? So rather than a straight line, have it flowing down the river channel?
Just mark.
Just mark multiple.
Click points along that profile.
Okay.
And then just double click when you finish it.
Okay, thank you.
Yeah, it doesn't have to be straight line.
Thanks. Anybody else?
Where can I see the volcano list of DEMs?
Yeah, so Gustavo shared a link on the chat. I don't know if you have it. Otherwise, it's on the Global Volcano Program database. So volcano.si.edu.
Okay.
Yeah, and then you got the volcano list. Yeah, and I just share it again. Thanks.
Okay.
Yeah.
Thank you.
So yeah, you can go there. Then you can look at the list. Yeah. Mm-hmm.
Yeah, I mean the function in the Victor library. There's one that looks for a volcano in the database, and then to grab a DEM from Open Topography, you just need to give it coordinates. So you don't have to limit yourself to the list of volcanoes. What you can do is figure out where your region is and put the center of it as the parameters for that function. So it can be the top of a volcano. We're just helping you with that database, or you can be any given location.
And so when you do that on Open Topography, do you have to be connected on Victor, or is it like separate?
I mean, that function that grabs a DEM from OpenTopo, you give it a location and a size, and then it calls OpenTopo.
Yeah. Okay. It's just that in this example specifically, I just grab the information from the GVP and then put that into the function. Whereas you can just skip that first step and say, I want somewhere in Morocco, and then you just take a little box there and give those long bounds, and that's that.
Yeah, like in interactive box, and cool.